The 3-in-1 Smart Car and IoT Learning Kit from SunFounder is a hands-on, all-included electronics kit that is perfect for anyone who wants to learn how to master the Arduino. The kit comes with an Arduino, 22 different sensors and modules, breadboards, jumper wires, and everything else you need to build a bunch of fun and interesting projects. Learn about robotics by building a remote-controlled smart car that can be controlled with an infrared remote controller, or drive on its own and avoid obstacles or follow a line. Learn about the Internet of Things with a project that lets you monitor the temperature, humidity, and light level of a room from an app on your smartphone. And build a plant monitor that tracks the temperature, humidity, light intensity, and soil moisture, and displays it on your smartphone so you can keep your plants watered remotely. It's a super cool kit, and I had lots of fun building all the projects in it. So click the link in the description below to order the kit from SunFounder. In this lecture, I'm going to show you how to set up PS2 joysticks. They're great for controlling things like robots, motors, and servos, but they can also be used for menu navigation. First, I'll show you how to read the raw sensor output from the joystick. Then I'll show you how to take that and use it to control things in the sketch. As an example, we'll build an LED controller that will fade on and off a set of LEDs with pulse width modulation when you move the joystick.
The PS2 joystick I'm going to use is a Keys KY023 module. SparkFun and Adafruit both make their own versions, and the setup and code we use here should work with any of those. These joysticks are basically just two potentiometers and a push button. One potentiometer is attached to the x-axis, and the other potentiometer is attached to the y-axis. When you push the stick in one direction, the resistance changes and the module outputs a varying voltage. It also has a switch that gets closed when you push the stick down. You can see the push button right here. Just like a regular potentiometer, the potentiometers on the X and Y axes output an analog voltage signal, and the push button creates a digital signal. There are 5 pins on this module: ground, VCC, VRX, which is the X-axis signal output, VRY, which is the Y-axis signal output, and SW, which is the output for the push button. This B103 indicates that these are 10 kilo-ohm potentiometers. The signal output by the joystick is an analog signal, so we need to use the analog read function to get the readings from it. Remember that the analog read function takes a voltage reading from the analog pins and converts it to a number between 0 and 1023. 0 corresponds to 0 volts, and 1023 corresponds to 5 volts. When the control stick is centered, the analog read value from each axis will be close to half of 1023, around 511. When you pull the stick back, the y-axis output signal increases linearly from 511 to 1023. When you push the joystick up, the value decreases from 511 to 0. So the axis travels the full range from 0 to 1023. The same thing happens with the x-axis. Moving the stick all the way to the right increases the x-axis output from 511 to 1023. And moving it to the left decreases it from 511 to 0. The push button switch is digital, and when you press it, the value goes from high to low. Now let's connect the joystick to the Arduino and get a readout of the raw values. First off, I have the ground pin of the joystick connecting to the Arduino's ground pin, and VCC connecting to the Arduino's 5V pin. The X and Y outputs are analog, so I have the VRX pin connected to analog pin A0, and the VRY pin connected to analog pin A1. SW is the switch output. That's a digital signal, so I've connected it to digital pin 7. The sketch isn't too complicated. We don't even need to use a library. What we're going to do is print the raw values of the joystick to the serial monitor. First, we need to define the pins that we're going to read the signals from. I created an int variable called xpin and set it equal to Arduino pin A0. This is the pin that's connected to the joystick's VRX pin. I also created a variable called ypin and set it equal to Arduino pin A1. That's the pin the joystick's VRY pin is connected to. Then I created a variable for the push button called button pin. It's connected to digital pin 7, so I set it equal to 7. In the setup function, I use the pin mode function to set the button pin 7, as an input with the internal polar persistor. Then I just initialize the serial monitor. In the loop function, I create a few local variables. These are going to store the readings from the joystick. The xval variable is set equal to the analog read value of the x pin. The yval variable is set equal to the analog read value of the y pin. The button val variable is set equal to the digital read value of the button pin. So each time through the loop, the Arduino will perform the analog read or digital read function on the joystick pins and store them in these variables. Now we want to print them out to the serial monitor, so we have the serial print function just printing out an x equals. After that, we print the value stored in the xval variable by using serial print with the xval variable inside the parentheses. For the y values, I do the same thing. I just put some space in here so it looks better. The yval variable gets printed next. Then the button value. The last serial print is a serial print line, so the next time through the loop the values will be printed on a new line. Then we just delay for 100 milliseconds to make the output easier to read. Let's upload this and check it out. So if I push the stick up, the y-axis values drop from 506 to 0. Pulling the stick back increases the values from 506 to 1023. Moving the stick to the right increases the x-axis values from 504 to 1023. And moving it to the left decreases it from 504 to 0. When the joystick is centered, the x and y axis values aren't quite halfway between 0 and 1023. I'm going to make a note of these values because I can use them to calibrate the joystick later. Now if I push the joystick, the button value goes from 1 to 0, as expected. Okay, now I want to show you how to use these values to control something. Let's set up a group of 4 LEDs, so that when I push the stick in one direction, the LED gets brighter, depending on how far I push the stick. I'm going to set up the circuit like this. The connections for the joystick will be the same as in the last example, but I've also inserted 4 LEDs into a breadboard. This is the up LED, this is the down LED, this is the right LED, and this is the left LED. I run a jumper wire from the ground pin of the Arduino to one of the breadboard's power rails. Then I connect a 330 ohm current limiting resistor from the ground rail to a row of pins in the breadboard. From that row of pins, I connect jumper wires to each one of the LED's cathodes. That's the shorter lead of the LED. We're going to use pulse width modulation signals to control the brightness of the LEDs. So I need to connect the LED's anodes to pulse width modulation pins. Those are the pins with the squiggly lines. The anode of the top LED will connect to pin 10, the bottom LED to pin 6, the left LED to pin 11, and the right LED to pin 5. In the sketch, we still have our variables that define the pin connections from the joystick. Now we need to declare some more variables to define the output pins for the LEDs. I've declared one for each LED: up, down, left, and right. In the setup function, we use pin mode to set the LED pins as outputs. Remember, we don't need to set the pin mode for analog pins, since they're automatically assumed to be inputs. The button pin is digital though, so we need to set it as an input with the internal pull-up resistor. Down here in the loop, we declare two local variables to store the analog read values from the X and Y axes outputs, just like the last sketch. The push button only outputs a high or low value, so I've declared a Boolean variable called button and set it equal to the digital read of the button pin. We're going to use pulse width modulation to control the brightness of the LEDs. Remember that we use the analog write function to send PWM signals to the PWM pins. The analog write function takes a value between 0 and 255. But the analog read values we're getting from the joystick are between 0 and 1023. So we need a way to convert each number from 0 to 1023 to a number between 0 and 255. We can do that with the map function. The map function will take a range of integers, like 0 to 1023, and convert them to another range of integers, like 0 to 255. So if we give it a value of 511, halfway between 0 and 1023, it'll be converted to 128, which is roughly halfway between 0 and 255. The map function takes 5 parameters. The first parameter is the variable that stores the numbers you want to be mapped. Say you have a variable called input range that will hold a range of numbers from 0 to 100, but you need that to be converted to a range from 0 to 10. Put input range here as the first parameter. The second parameter is the lower end of the range you want to convert from, so this would be 0. The third parameter is the upper end of the range you want to convert from, so you'd put 100 here. The next parameter is the low end of the range you want to convert to, so this would be 0. The final parameter is the upper end of the range you want to convert to, so this would be 10. So this will take a value from the input range variable between 0 and 100 and convert it to a number between 0 and 10. And that mapped value will be stored in this mapped range variable. We need to do the same thing with our analog read values from the joystick. The analog read function returns an integer from 0 to 1023. But the analog write function, the function that creates the pulse width modulation signal, needs an integer between 0 and 255. The map function takes an integer and returns an integer, so I declared a local int variable here called up_pwm, and it's set equal to the map function. The first parameter is the y_val variable, which holds the analog read value from the y pin. When the joystick was centered, the analog read of the y-axis was 511, and when I pushed it up, that decreased to 0. I want the up LED to increase in brightness when I push the joystick up, so the low end of my input range is 511, and the upper end is 0. Since I want the up LED brightness to increase from off to full brightness when I push the stick up, I want the low end of the mapped range to be 0, and the upper end to be 255. So now, when the analog read value for my y_val variable decreases from 511 to 0, the map function will convert it to numbers that increase from 0 to 255. And that will be stored in the up PWM variable. The down LED is similar. The analog read value is 511 when the joystick is centered. When the stick is pulled down, the value increases to 1023. So the low end is 511, and the high end is 1023. We need that mapped to a value between 0 and 255. So the low end is 0, and the high end is 255. And that's stored in the down PWM variable. I'll use variables called left PWM and right PWM to store the map values from the X pin. The first parameter in the map function is the xval variable, which stores the analog read value from the X pin. When my joystick was centered, the x-axis analog read value was actually 495, not 511. So I'm going to use 495 instead of 511. When I push the stick to the left, the analog read value decreased from 495 to 0. So the low end of my range is 495, and the upper end is 0. I need the mapped value to increase from 0 to 255 when I push the stick left. So the low end of the mapped range will be 0, and the upper end will be 255. And that will be stored in the left PWM variable. For the right LED, the low end is still 495. But since the value increased when I pushed the stick to the right, the upper end of the range will be 1023. And that needs to be mapped to a range between 0 and 255. Now that we have the analog read values mapped to numbers that the analog write function can use, we just need some analog write functions for each LED. We need to use if statements for this. Each LED is going to have its own if statement, with the analog write function inside. The condition of each if statement will be the range of analog read values that correspond to the joystick's motion of travel. For example, I only want to write the up LED when the analog read value of the y-axis is between 511 and 0. So here I have if y-val is less than or equal to 511. Analog write the up LED, the mapped up PWM value. For the down LED, the y-val increases from 511 to 1023. So I have if y-val is greater than or equal to 511, analog write the down LED, the mapped value of the down PWM variable. For the left LED, the analog read value decreases from 495 to 0. So this is xval less than or equal to 495. And for the right LED, the value goes up from 495 to 1023. So the condition is xval greater than or equal to 495. When I press the push button, I want all of the LEDs to turn on at the same time. So I have another if statement here. Pressing the button pulls the pin low. So I have if button equals low. Digital write all of the LEDs high. There are separate digital write functions for each LED. Up, down, left, and right. And they're all switched high. Okay, let's check this out. I have my up, down, left, and right LEDs connected here. And here's the joystick. I'm orienting the joystick with the pins to the left. If you want to orient the joystick another way, the analog read values in the map functions will need to be changed. Alright, so when I push the joystick up, the up LED fades on. When I pull it back, the down LED fades on. Left and right are working too. And when I press a switch, they all turn on. Now in the next video, we're going to learn about interrupts. Interrupts are a way to make sure the Arduino detects each and every input you give it.
SunFounder is my go-to source for sensors, modules, and other parts for the Arduino and Raspberry Pi. They have a huge selection of STEM, robotics, and IoT kits, and lots of useful sensors and modules. Every product has an online tutorial with wiring diagrams and example code. They also offer free shipping on all orders, with no minimum. Give them a try at www.sunfounder.com next time you need to order some parts.